how can we catch up with Asia? How can we improve in producing our batteries the way that Asia is doing it?
The battery cell is one of the few components or products in the world where probably a higher quality might result in lower prices.
I would think that the quality that Europe and North America is capable of producing with batteries would be superior to what Asia does.
The main challenge is to really understand the production processes in its core, and thus being able to reduce the scrap numbers.
I have a feeling that the industry was sleeping too long on really getting into discovering and engineering new technologies, new processes for advanced batteries.
I'm still confident that we will have a bright battery production future in Europe.
Hello and welcome to another episode of Converting Conversations. We will be discussing the complexities of battery manufacturing, the impact of new cleaning technology, and the future of automation in this rapidly growing industry. So let's dive in. I have two great guests to bring on today. Marcel Treasure is Research Associate, Production Engineering of E-Mobility Components, RWTH Aachen University. And Dennis Spanish is Product Line Leader with BW Converting's Baldwin branded surface treatment, cleaning, and spray products. Thank you both for being with me today.
Thanks for having us.
Thank you for having us.
Looking forward to getting into the conversation. Before we do, can I ask you each to give us a brief bio if you can? Marcel, starting with you, please.
Yes, of course. So, I started my academic career at the RWTH Aachen University. First off, by studying mechanical engineering. And then I did a dive into the EV industry right away. For now I'm working at the chair for production engineering of e-mobility components, focusing on battery production.
Wonderful. And you, Dennis?
Yeah, thank you, Michelle. So I've started my career as a mechanical engineer for cleaning systems. 3 years ago, I turned the engineering leader for all cleaning related products for Baldwin. And now since over 1 year, I'm the product line leader for a bigger portfolio.
I want to talk more about the EPIC system. What inspired its development? How does it help manufacturers overcome challenges like bottlenecks, especially in maintaining clean, efficient operations?
So it was all inspired by also a workshop in 2019 where we looked into how can we transform our core strength into new emerging markets. I was happy enough to lead one of those workshops with the cleaning engineering team, and we identified that there's a future need for EV batteries, right, for electric vehicles. Luckily enough, we stumbled over the need for the calendaring process where the coated material of anode and cathode slurries, which is coated onto the metallic film, is overpressed to get the density and to get it more dense and get porosity out of the system. And during that process, when you overpress that semi-dry material in these calendar rolls, you create a lot of residues on the rollers. We learned that quality is a key aspect for every customer of advanced batteries, and also eventually for cars, because it can affect the range of a car and stuff like that. So we learned quality is key, and it plays a role for the battery producers if they run their machine for 1 hour, for 20 hours, or for 50 hours, because during that time you always have a different kind of buildup on the rollers, and you would produce a different quality level of film material. So cleaning, of course, is one solution to that. But due to the high temperature on the cathode side, which is up to 150 degrees, that was not doable to this point. So we looked into a solution to make that doable, make that feasible. And like I said, with the identification and also the positive proofs and testing of our chemical liquid for cathode cleaning, we were capable of doing a fully automatic cloth cleaning cycle, which is integrated into calendaring stations.
What are the practical advantages of automating the roll cleaning process with the Epic system? What impact does this have on not only reducing downtime, but essentially making your bottom line better?
If you think about a calendaring surface that is a metallic surface that is 150 degrees and it's also turning, you should never touch that. The only alternative to the Epic system is doing a manual wash, which means cooling it down, but also heating it up again. So that is a huge saving, being capable of cleaning your rollers at their production temperatures in just 2 or 3 minutes, while the process of cooling it and heating it up again can take from 8 all the way up to 16 hours. So it's at least a saving of 8 hours. We have surveyed so many players in that industry, OEMs, operators, also integrators of gigafactories. So I can say for the cathode production, which in my belief is the main bottleneck, you can say that they have to clean their calendaring line up to 8 times a week, which is more than 1 time a day, but for sure 3 times a week. If we saved you 8 hours for 3 times a week, that will make up to 1,200 hours of downtime saving for that one calendaring line.
So, looking ahead, what future advancements in technology like the Epic system do you think will be essential for improving efficiency and quality in battery manufacturing?
I see opportunities in cleaning, in drying, basically also in the coating or in the surface treatment before you apply the coating. That could also help to improve or reduce the scrap rates, in my beliefs. So that's where I see potential. But I think Marcel, that's what he's doing every day.
Most of the scrap is being produced in the electrode manufacturing. Even the scrap that, when you look at statistics, is produced in the formation steps, is rooted to the electrode manufacturing. So having a very close look at that process step is very important, and I strongly agree. And then it comes down to to understanding the interdependencies between mixing, coating, and calendaring.
Can you walk us through the critical stages in battery manufacturing, such as electrode production, cell assembly, and formation, and then explain the role that each stage plays in delivering a quality product?
Yes, of course. So we start off by mixing some of our raw materials together, forming a slurry, and then coating them onto the electrode foil, usually copper or aluminum foils. And these two processes alone are very complex, but it doesn't stop there. And then afterwards, we have different drying steps, and we have the calendaring afterwards, where the coated layer on the electrodes is being compressed. And then we get into the cell assembly, where, from a mechanical point of view, our cell is being formed. So we start off by cutting our electrode sheets to a desired shape, and then forming cell stacks, for example, or jelly rolls. And then, putting all that together in a housing. So we have a mechanical cell that looks like a final battery cell as we know it. But then even the production process doesn't stop after that. We still have the formation steps after that, which is basically the first charging and discharging of the battery cell. Many different electrochemical reactions happen. The interconnection between all these different process steps is very, very complex.
With that whole process that you explained in the steps and the procedures and the complexity, how does the need for quality control factor into these different stages, especially with factors like particle contamination and layer uniformity in electrode manufacturing?
The main challenge is to really understand the production processes in its core, and thus being able to reduce the scrap numbers. That's everything revolves around that aspect of increasing the battery production quality and quantity. The less scrap is being produced in the end reduces the cell prices in the long term.
And Dennis, I know you're out and about everywhere and meeting a lot of people in the industry. What's your take? What do you hear from the people that you've connected with when it comes to quality over quantity?
Well, I've been at a couple of seminars, conferences in Europe, in Northern America, and you hear that there's always the same spirit. Like, how can we catch up with Asia? How can we improve in producing our batteries? How can we find new technologies and new innovative things that can give us a chance on making up with where Asia is already? If we look back for 5 to 10 years, where it was very much more obvious than it is probably today, you could always see that a product coming out of Asia lacks in quality. Maybe it's a false perspective on the things at this point, but I would think that the quality that Europe and North America is capable of producing with batteries would be superior to what Asia does, and that they are far superior in producing the quantity that we need at this point.
While that might be true for some other industries, I, to be honest, disagree for the battery industry. From my opinion, they win in both worlds, so to say. Those two things are linked. The battery cell is one of the few components or products in the world where probably a higher quality might result in lower prices. And that sounds paradox in the first glance.
The amount of scrap that is produced is in the second or in the double digit area. So if you would think that a company is producing 10, 15, 20% of waste, they would as well be capable of producing a product at 10, 15, 20% lower costs if they get all the scrap out. So that's an easy formula. The Asian producers are far ahead of us at this point.
Earlier, we talked about the great debate, quality versus quantity. How has the EPIC system impacted production quality or yield in battery manufacturing? Are there any specific case studies or results that you can share that demonstrate its effectiveness?
Yeah, we are just about to start a case study, start a white paper. So that's in the pre-development, also together with Marcel. So we kind of put our heads together already a little bit. That will happen in fiscal year 25. I'm quite sure it needs to happen to really refer to that case study and make sure everyone really sees the true benefit of the system. I've been seeing it myself. I was standing right next to the machines. You can see the operators cheering when they realize their process, which usually takes the line down for 8 hours, and then it's a 45, 50-minute time of kneeing down into the machine and cleaning the thing by hand. They were really, really happy to see that our automatic solution was capable of doing it in a couple of minutes.
Dennis, you mentioned the white paper that you definitely want to do it in 2025. Tell me about the process there. What's entailed, and are there partnerships involved?
So you need basically 3 parties to do that white paper in the best possible way. You have us as the technology provider. We want to make sure and prove the value for the customers of our cleaning method. Talking about the 25% boost in productivity, but also the 1,200 hours of downtime savings. That all has to be proved in a white paper, and we understand that. And there's 2 more parties involved. One of them is a good industry partner who's giving us access to his machine park, to his gigafactory, to his production line, so that we can place our system and have a live test in a live environment. In a large scale as well. So we have been selling this system a couple of times now, but never into a large gigafactory that provides access as well. And the third party that we need is scientific support. And Marcel, why don't you explain your role in the white paper?
So, well, yeah, as a scientist, writing papers is basically our daily business, so to say. And so in that constellation, yeah, we would be the neutral, independent entity and doing all the scientific work behind the white paper and ensuring that all the results that end up in the white paper are spot on.
So hearing a lot about partnerships and how they are so important with the white paper, but let's talk about the big picture. How important are partnerships when it comes to everything really that we're talking about today?
There's a lot of things are happening in the research, and all of that is of no value if we cannot transfer all this knowledge in the industry. And that happens through these partnerships. We actually focus a lot of our work on working together with industry, supporting industry, and propelling their businesses, their technologies.
That setup that we have there in Aachen is also allowing us as a business, us as a company, to get access to the scientific work, scientific environment at the university, but doing that in a commercial way. And that's why we see so much value with Marcel's team, and which is why we are looking forward to further collaborations, further partnerships, and hopefully completing the white paper in 2025.
Marcel and Dennis, thank you so much for joining us, sharing your valuable insights on the current state and the future of advanced battery production. You definitely have expertise in the industry. You've seen the challenges. We talked about some solutions, innovations, of course, like the EPIC system. And I'm sure you gave our audience out there a lot to think about. So I appreciate your time today. Thank you for being here.
Thanks for having us.
Thank you, Michelle.
And to our listeners, thank you for tuning in to Converting Conversations. Stay tuned for future episodes where we continue to explore the latest industry trends, technological advancements, and success stories shaping the world of manufacturing and production. I'm your host, Michelle Dawn Mooney. Thanks again for joining us. We hope to connect with you on another podcast soon.